Hey everyone, so I wanted to make a video to explain the difference in polarity between the trans and cis isomers of Stilbene or Stilbene, however you want to pronounce it. And I'm talking in this video about this specific lab that we did, but um, it doesn't really matter. But this is the reaction in this lab. So this lab is the Wittig reaction or the Wittig reaction to synthesize the Stilbene isomers, and this one would be the side product of the reaction. Obviously, the side product is more polar than these two, but it's hard to tell which one is more polar, the cis or the trans, because they are both non-polar, because they are both made of only carbon and hydrogens, which not differ so much in electronegativity, but one of them is more polar, and they do separate slightly in the TLC paper, and let's see why. So this is a trans and this is a cis. The trans is solid in room temperature. 25 is below the melting point, which is the room temperature. But 25 in the cis Stilbene isomer comes between the melting point and the boiling point, so it's liquid in room temperature. And if we look at the molecule and relative to the double bond, we get like two vectors. One is up, one is down. And if you remember in physics, the sum of two vectors, that one goes up, one goes down in the same direction, they would cancel out. So the electrical dipole would be zero in this compound. So it's non. So it's both of them are non-polar, but this one would be the least polar, because if we drew the vectors here, the sum of them would be downwards. Or if you drew them like the two um, benzenes upwards, and the sum would be like they would go like this, and the sum would be upwards. Either way, they do have a sum, and that's why they do have a dipole moment. So the cis Stilbene is more polar than the trans one. And if we do like the TLC paper and we get like 3 points, let's call them A, B, C. So A would be the most polar because TLC paper is made of silica, which is very polar. So the more polar loves polar. So the most polar one wouldn't go too far, would have the lowest RF value. So A would be our side product because it's more polar. B would be cis because it's more polar than trans, and C would be the trans isomer. And in this specific lab, the first thing that we do to separate the three is that we use cold ethanol. And ethanol, because of its polarity, so in cold ethanol, these two would be soluble, but this one would crystallize. Okay, and we filter this out, and like we separate this one, and we are left with these two, and then they differ in polarity, so it's easy to separate them. So basically, we use fractional um, crystallization in this lab. So first we crystallize this one, and then we crystallize this one, and then we are left with this one. So that's how we separate these three. Obviously, there are more ways to separate them, but in this specific lab, we use this one. If you have any other questions, you can message me or comment, and I would gladly help you in this lab. Thank you, and I hope this helped you a little.